Hey guys, so our main focus this week is on water quality. And when we're talking about water quality, we're talking about the measure of certain physical or chemical and biological characteristics of water. These might include properties like water temperature, the pH level, how much oxygen is in the water, how much sediment, and whether or not organisms can live in the water. So we talk about water quality, we often refer to it as being good or bad, but what do those terms actually mean? So when we go into specifics, we're focusing on different characteristics, and we're going to focus in on them specifically from this list to the left. But before we do that, the whole idea of water quality and that organisms need good quality water to survive. Humans are no exception. So, what may be good water quality for one organism may be poor for another. And a change in water quality can be bad for plants, it can be bad for animals and other living things that already live there, but good for other types of organisms. So, it's finding that balance with water quality and its effects on living things. And scientists can assess water quality by monitoring changes in the ecosystem. They can track changes in water quality. If a body of water or source of water is monitored over a length of time, the scientists can actually end up determining when a significant change occurred. So they can present data to communities and hopefully encourage them to take action to protect the water. So some of the ways that scientists go about testing water quality, like I said, are from the list to the left. So water temperature is very important because when you have warmer temperature water, it's actually going to lower the amount of dissolved oxygen. Well, what is dissolved oxygen? Dissolved oxygen is actually the amount of oxygen that is in the water source. So from this diagram, you can see that in the top portion of the water, you have 100% dissolved oxygen. And that is because dissolved oxygen is made from plants. We know that plants on Earth produce oxygen as a byproduct. It is the same exact thing in the water. So you have algae, phytoplankton, plankton that produce oxygen and is actually delivered and stays in the water. So this is oxygen that the animals that live within that ecosystem use to breathe. So it's like fish breathing in the oxygen with their gills. That's the oxygen that they're receiving. So when we have dissolved oxygen, a higher amount of dissolved oxygen is the best. You can see from this diagram that it's a range. So if you have more aquatic plant life, you're going to have a higher amount of dissolved oxygen. When you see areas of, you have that slimy algae growth, known as algae blooms. Sometimes they're green, sometimes they're red, depending on what type. That's actually bad because the sun can't penetrate and get through the water, and it ends up being detrimental to the water source. So a lot of the organisms end up dying, the fish, all the little critters that make up the organisms that live there. So when you have more plant life, it's going to be beneficial, and you're going to have a higher rate of dissolved oxygen. So this is saying too low for fish populations in this range, but the more dissolved oxygen or parts per million, it's going to increase. And you can see around the halfway mark to 10, obviously 10 being the highest, it supports the most abundant fish populations. So even within this, it's not just fish, it's any type of organism. There might be organisms that can live in areas that have low dissolved oxygen, but you're not going to have an abundant type of biodiversity or diversity in your organisms that make up your ecosystem. So when we talk about this list, all of these are kind of intertwined with each other. They all relate. Water temperature relates to the pH level, relates to the dissolved oxygen content, relates to the turbidity, and relates to the bioindicators. So they all work hand in hand to describe the water quality. And if one is too high, it affects the other. And so there has to be a balance with these. So if we continue to talk about, let's say, where's my pH? There it is. So let's move these back out of the way. So we've talked about the pH scale before, but water is in a neutral state. It typically has a pH of 7. That's going to be a very neutral, right smack dab in the middle of the pH scale. So if you were to test or take a water sample and you had maybe a rating of a 5, that means that it's going to be more acidic than that middle range. So yet again, some organisms may like and can live in water that's around a 5, but it's still limiting. So it doesn't mean you're going to have a vast variety of organisms. So scientists use the pH scale to see the health of the water as well. So when we're talking about turbidity, we're talking about the clarity of the water, the amount of sediment that is located in the water. So you can see the difference between the container on the left and the container on the right. The container on the left has a very low turbidity. The container on the right has a very high turbidity. So high amount of sediment, low amount of sediment. Well, what factor does this play? What role does this play in the health of the water? Well, if you have water with very low turbidity, it allows that sunlight to travel through. Well, what did we say the sunlight does? The sunlight allows for oxygen production with the aquatic plants, making that byproduct of oxygen. So if that sunlight can't travel through, like in this high turbidity container, it's going to make it a lot harder for those plants to make oxygen. They're not getting that sunlight, and that chemical reaction's not happening for the role of oxygen production to happen. So these things go hand in hand with, yet again, water temperature, yet again with dissolved oxygen. So if you have high turbidity, you typically have a high water temperature. Well, high water temperature, if it gets too high, is going to limit the health of the water and lower the amount of organisms that can live there. Certain organisms can't live in warm water. They need kind of a mild temperature. So if the temperature's high and the dissolved oxygen's low, that's going to limit the amount of organisms yet again. So turbidity plays a role in dissolved oxygen and water temperature. And all of these things now play a role in bioindicators. And just like it sounds, bioindicator, an indicator gives you an idea about something, and bio we know means life. They go hand in hand. So it's going to tell us what kind of life lives in that area. So from this diagram, you can see this is going to relate to the benthic microinvertebrates that are found in the ocean. So the water quality that relates to that. With good water quality, you have lots of different organisms. And basically, it's just saying that these organisms can survive in different types of water quality. So very low water quality, these organisms can survive. These are tolerant of decent water quality, and these are very sensitive, meaning if this benthic zone did not have good water quality, these organisms wouldn't survive. So that's not saying that these would not survive in good water quality. It means all of them would survive. These just can survive even if the water is very poor. So there is a difference. So we're looking for a vast variety of different organisms that live in this benthic zone. So the more organisms you have, the better the water quality. That's what it tells us. That's what it's indicating to us, that the water is healthy because you have more organisms that can live there. So these are all aspects of good water quality. We have turbidity, we have bioindicators, we have the amount of dissolved oxygen. Remember, the higher amount of dissolved oxygen, the better. And you can see as well in this diagram, if we go back to it, this bottom level of the ocean or water system, like we said, dissolved oxygen relates to how much sunlight production there is for photosynthetic purposes. So that sunlight's hard to reach down here, and that's where we get that benthic zone. So you're going to have much more decomposition happening. And because of that, you're going to have a less rate of dissolved oxygen. There's still some, but it's not going to be the high rate like if this was the intertidal zone, where you have a vast variety of plant life and aquatic organisms as well. And then lastly, like we said, we have the pH scale as well. So the pH level. All of these are different ways that we test for water quality. All of them are important. All of them go hand in hand. You can't have one without the other.